In this video, we're going to go through a polar graphs test review. We're going to go through 31 questions together. If you want to try some of these problems on your own, go ahead and pause the video and then we'll go through them together. We're going to be working with these formulas here on the right. You might want to copy them down so you can have them to reference, but we'll talk about how to work with them as we go through this video. We're going to be talking about a lot of different topics as far as graphing polar coordinates, changing from polar to rectangular coordinates, and vice versa. We're going to talk about rewriting rectangular equations into polar equations and polar equations into rectangular equations, as well as drawing the different polar graphs. And given a polar graph, how to write the equation. So a lot of different topics that you're likely to see on your upcoming exam. Let's dive into this video. The first 6 questions, what we want to do is we want to plot these points on this polar graph, basically. Now remember, it's r comma theta. So the r represents like the distance from the pole, almost like a radius. And theta is like your angle of rotation. Remember, when you rotate counterclockwise, it's positive. Negative is a clockwise rotation. So for this first one, 4 comma negative pi over 3, you can do this a couple different ways. One way I like to do it is, okay, go out to a circle of radius 4, so 1, 2, 3, 4. And then negative pi over 3 means it's like a negative 60 degrees. So I'm rotating clockwise, negative 60 degrees. So 1, 2, 3, 4, be right about here. So this is point number 1. Now another way to do this is you could first rotate negative pi over 3, find that line or that angle, and then go out from there. Now if it's a negative r value, it would go through the pole the other direction. Okay, so let's do number 2 now. This one's 3, 5 pi over 6. So I'm going to go out to a circle with radius 3, that's right here. I'm going to rotate 5 pi over 6, which is 150 degrees. That's going to put us right about here. So that's point number 2. For number 3, we have negative 5 comma pi. So one way to do this, negative 5, is I could go to the left. Since it's negative, I could take a 1, 2, 3, 4, 5. And then pi, this is a positive angle, so I'm rotating counterclockwise, which is going to put us right here. So that's number 3. Now another way to do this is you could say, well, let me go over to pi. Okay, that's 180 degrees, but because we have a negative r value, we go through the pole to the other side. So a couple different ways to look at it. Number 4, we've got negative 6, negative 3 pi over 4. So the way I like to do it, if it's negative, I go to the left. 1, 2, 3, 4, 5, 6. Okay, negative 3 pi over 4, it's a negative angle, so we want to go clockwise 3/4 of pi. Pi is 180, we're going 3/4 of that rotation, so that's going to be point number 4. And then for number 5, 1 pi over 2. This one's kind of easy. It's a r value of 1. We're rotating counterclockwise 90 degrees, or pi over 2. That's number 5. And then the last one, number 6 here, we have negative 7 comma pi over 2. So negative 7, I like to go to the left. 1, 2, 3, 4, 5, 6, 7, because it's negative. And then pi over 2, it's positive pi over 2, so I'm going to go counterclockwise. That's going to put us right here. Now, I could do the angle first. I could rotate pi over 2. This is the pi over 2 line. And because it's a negative 7, instead of going up, I'm going to go through the pole the other direction here. So a couple different ways to look at it. Let me erase the whiteboard. Let's get into the next group of problems. Okay, so we're going to go from the polar coordinates to the rectangular coordinates. So remember, this is r comma theta. And we want to go to x comma y. So how do we do that? Well, we're going to be working with these 2 formulas right here. And you might be saying, Mario, where do those formulas come from? And what you want to reference is this circle right here. I'll make it a little bit larger. What you have is you've got the radius of the circle, but this point, you can get to this point by going right x and up y, right? And the central angle here is theta. And if you take the cosine of theta, remember how cosine is equal to adjacent over hypotenuse? So if you multiply both sides by r, you get x equals r cosine theta. And it's the same thing for y equals r sine theta, coming from this triangle. So what we're going to do is, to find the x coordinate, I'm just going to do r cosine theta. To find the y coordinate, r sine theta. So r is 2 times the cosine of 3 pi over 4, and 2 times the sine of 3 pi over 4. Now here's where you want to be real comfortable with the unit circle. And if you need to, you can reference my unit circle videos on my Mario Math Tutoring YouTube channel. But at 3 pi over 4, cosine, the x-coordinate, is going to be root 2 over 2. And sine of 3 pi over 4 on the unit circle, that y-coordinate is going to be also root 2 over 2. But here cosine, we're in the second quadrant, so that's going to be negative. Okay, the sign is going to be positive. Okay, so now let's just simplify. This is like 2 over 1, so these 2's cancel. Same thing here, 2 over 1, these 2's cancel. So we're getting negative root 2, comma, positive root 2. And that's your x comma y. Now, if you were to graph this, negative root 2, positive root 2 puts you right here, which if you think about it, this is a radius of 2, and it's an angle of 3/4 of pi, or 3 pi over 4. So it's just another way of getting to that point. Instead of going left and up, you're going a radius of 2 and you're rotating 135 degrees. Now for number 8, same idea. We're given r comma theta. We want to go to x comma y. So the way I like to set this up is r, the radius, times cosine of the angle, and then r, the radius, times the sine of the angle. Okay, so now what do we have here? We've got cosine of negative pi over 6. Now in your unit circle, negative pi over 6, that's negative 30 degrees. You know this point is root 3 over 2, comma, negative 1/2. So let's go ahead and make that substitution. Cosine is the x-coordinate, sine is the y-coordinate, and we're multiplying by negative 5, which is like 5 over 1, or negative 5 over 1. And then if we simplify, this comes out to negative 5 root 3 over 2, comma, 5 over 2, okay? And then sometimes I like to just kind of analyze it a little bit to see, if this makes sense. Well, on our polar graph, see, if we rotate negative pi over 6, that's like a negative 30. So this is like our negative 30 line here. But because the r value is negative, we go through the pole, okay, to the other side. So a circle with radius 5, that would put us right here. In rectangular coordinates, you can see we're going left, negative 5 root 3 over 2, up 5 over 2. So you can see we're getting to the same location. This is more like a circular way. This is more of a left and right, up and down sort of rectangular form. Let me erase the whiteboard. Let's do the other direction, going from rectangular to polar. Okay, now going from rectangular coordinates to polar coordinates, that's from x comma y to r comma theta. We're going to be using these formulas right here. Okay, and so let's go ahead and do that. So we've got x comma y. We want to find the radius. So that means we're going to do radius is the square root of x squared plus y squared. So let's see what that is. So x squared would be 6 squared plus 6 root 3 squared. 6 squared is 36. 6 squared is 36. Square root of 3 squared is 3. 36 times 3 is 108. Which means that this is 144, and the square root of 144 we know is 12. Okay, so that's our radius. Okay, now our angle, theta, we can use this formula right here. Theta is the tangent inverse of y over x. Again, this comes from this triangle right here, if you want to understand that a little bit better. Sometimes what I like to do is graph it, and so what I would do here is I'd say, okay, I'm going right 6, up 6 root 3, and this angle right here, you can tell that this is a 30, 60, 90 triangle because remember the ratios x, x root 3, and 2x. So I can tell that this is a 60-degree angle, or pi over 3. But let's say you don't recognize it at first like that. You can use a calculator. You can also do this right here, which is theta equals the tangent inverse of y over x. So that's 6 root 3 over 6. The 6's cancel, and now we say, okay, tangent of what angle equals square root of 3? Well, on the unit circle, at 60 degrees, we know this point as 1/2 comma root 3 over 2, and the tangent's y over x, so this will come out to root 3. So a couple different ways to do it. Again, you could use a calculator. Sometimes it's no calculator type test, so you'd want to know those special right triangles, like your 30, 60, 90, and 45, 45, 90. So r comma theta. Okay, so for number... Oh, and one thing I forgot to mention is that there's some restrictions, and the reason your teacher will put some restrictions is because really in polar, you could have many different answers. You could go around the circle many times this way, or you could have a negative r value, a positive r value. So here it wanted the radius or the r value to be greater than or equal to 0, and the angle it wanted to be from 0 to 2 pi, so like a positive angle. So for number 10 now, we want to use a negative r value, and we want the angle to be between negative 90 and positive 90. I like to graph just to kind of get a little visual, but basically our graph looks something like this. We're going left 4 and up 4, okay? Make a little triangle, negative 4, 4. And so you can see that that radius of that circle, that hypotenuse, is going to be 4 root 2, right? So this is actually like a x root 2. It's a 45, 45, 90. This is isosceles. The two sides are congruent. And so if I know this is a 45, that means that this angle here would be 3 pi over 4. But you see how this wants an angle between negative pi over 2 and positive pi over 2? So what I could do is I could say, well, let me make this a negative pi over 4. Okay, so for our angle, negative pi over 4. And then see the r has to also be negative, so I'm going to go through the pole to the other side. That's going to be negative 4 root 2 for our radius. Okay. Now again, we can use these formulas. We could say r equals the square root of x squared plus y squared, so negative 4 squared plus 4 squared. So that's 16 plus 16 is 32. The square root of 32 is 4 root 2. The angle, we can do tangent inverse of y over x, so that's going to be 4 over negative 4, so that comes out to negative 1. Where is tangent equal to negative 1? Well, it is at negative 45 or negative pi over 4. It's also negative 1 over here at 135 or 3 pi over 4, but we want to be in this restricted domain here. Okay, so let's go to the next one. See if you can do this one. 2 root 3 comma negative 2. Again, I like to draw a little picture just so I know what I'm dealing with here. So I'm going right 2 root 3, and then I'm going down negative 2. Okay, so then I can see that this is x root 3, and 2x. So this would be 4. So I can see that this is like a 30-degree angle there. Or you could say negative pi over 6. Now in this case, it wants us to have a positive r value and a positive angle between 0 and 2 pi. So I could make this angle 11 pi over 6, okay? So that's our angle, 11 pi over 6. Okay, and then the r value we said was 4. So this is a circle with radius 4. Now, some people don't like to do it like this. I'm kind of more of a visual person. I like to kind of see it to believe it. And the other thing here is that, let's go ahead and do the formula. So to do the formula, we would do the radius, which is equal to the square root of x squared plus y squared, which is negative 2 squared. So negative 2 squared is 4. 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12, so 12 plus 4 is 16. The square root of 16 is 4, which is what we got here, okay? R is greater than or equal to 0, and then our angle, we can use the formula theta equals tangent inverse of y over x. That's this formula right here, and that would be negative 2 over 2 root 3, which reduces to negative 1 over root 3. You could rationalize it to negative root 3 over 3. Where does that occur? That occurs at negative pi over 6, or if you wanted a positive angle like we do here, it would be 11 pi over 6. So again, you might need to refresh on your unit circle. You can check out some of my videos on that if you need help. Let me erase the whiteboard. Let's do the next type of problems. What we want to do is we want to write the polar equation in rectangular form. So before we were working with the coordinates, now we're working with the equations of these polar graphs. We want to put them into the x, y, or rectangular form. So we're given this r sine theta equals negative 2. And we want to get rid of the r and the theta, and we just want to be left with x's and y's, right? So using some of these formulas here, I can see that r sine theta is equal to y. Okay, so I'm going to replace this with y, and so I just get y equals negative 2. Now, if possible, you want to try to write it in the form y equals mx plus b, or you try to get y by itself. Sometimes you can't do that. It might be like a circle or some other conic section. You can put it in the standard form of that particular graph. Let's look at number 13, r equals negative 1. Okay, now I know that r is equal to the square root of x squared plus y squared. So let me make that substitution. Okay, if I square both sides, I get x squared plus y squared is equal to negative 1 squared, which is 1. And you can see that this is the standard form of the equation of a circle. R equals negative 1 in polar. It doesn't matter, like negative 1, I would go here, left 1, and then I'd say, oh, what's my angle? Well, it could be, 30 degrees or 45 or 60. So basically it traces out a circle with radius 1, and this is the standard form of the equation of a circle with radius 1. For number 14, we have r equals 3 secant theta. Okay, now we know from our trig identities that secant is the reciprocal of cosine. So I could write this as 3 over cosine theta. If I multiply both sides by cosine theta, r cosine theta is equal to x. So this is going to be x is equal to 3. And that's a vertical line in rectangular form. For number 15, we have r equals 2 cosine theta. Okay, so here what I'm going to do, and this might, once you see it, you'll kind of understand how this works, but what I'm going to do is I'm going to multiply both sides by r. So if I multiply this by r and this by r, keeping the equation balanced, doing it to the left and right sides, but what's r cosine theta? That's x. So that's going to give us 2x here. This is going to give us r squared, which we know r squared is equal to x squared plus y squared. Now, when I look at this, I can see that this is a circle, but let's write it in the standard form of the equation of a circle. So I'm going to subtract the 2x. I'm going to complete the square. I'm going to say half of negative 2 is negative 1. Negative 1 squared is positive 1. If I add 1 to the left, I want to add 1 to the right. And then if I factor this, this is a perfect square. And I can see there's the center of my circle, 1, 0, and it has a radius of 1. Let me erase the whiteboard. Let's do the next group of problems. Okay, now what we're going to do is we're going to write the rectangular equation, the xy equation, into polar form, which is in terms of r and theta. So see if you can do some of these problems here. Number 16, x equals negative 8. Well, I know that x is equal to r cosine theta. So let's make that substitution to get rid of the x and get everything in terms of r's and thetas. Ideally, what you want to do, if you can, is you want to either get r by itself, or sometimes we're going to get like theta by itself. Just like how we try to get y by itself if it's like a line or a y equals equation in rectangular. So here I'm going to divide both sides by cosine theta. Now it's not always possible, but we try to clean it up, and if you can, get r by itself. So this is r is equal to negative 8 over cosine, and we know the reciprocal of cosine, 1 over cosine, is equal to secant. So this is negative 8 secant theta. Okay, for number 17, we have x squared plus y squared equals 4. Again, I want to get rid of the x's and y's. I just want r's and thetas, and I know that r squared is equal to x squared plus y squared. So I can make this substitution. R squared is equal to 4. If I take the square root of both sides, I get r equals 2. And that makes sense because this is the equation of a circle with radius 2. Remember how this is r squared. And this is also a circle with radius 2. But notice the polar is a lot simpler. R equals 2. It's just a r value of 2, a radius of 2. For number 18, y equals 20. Well, we know y equals r sine theta. So let's go ahead and make that substitution. Again, if we can, we try to get r by itself. So let's divide both sides by sine theta. And we know the reciprocal of sine, or 1 over sine, is cosecant. So this is going to be 20 cosecant theta. R equals. Let me erase the whiteboard. Let's do the next group of problems. Now we're going to do some graphing. We're going to graph these polar graphs. So for number 19, we want to graph theta equals 5 pi over 6. So notice that there's not an r value here. We don't know what that radius is, or that distance from the pole, okay, or the origin. But we do know that that angle, theta, is 5 pi over 6. That's like 150 degrees. Now, if the r value was 1, the point would be right here. If the r value was 2, the point would be right here. If the r value was 3, it'd be here. If the r value is 4, it's here. So you can see that it's any point. Now, if it was a negative 1, the r value would be here. If it was a negative 2, because you go through the pole the other direction. So we're basically any point on this line, on this 5 pi over 6 line, that's our polar graph. Okay, for number 20 now, r equals 5. Now notice this one doesn't have a theta. It doesn't say what the angle is. It says that the r value is 5, 1, 2, 3, 4, 5. The angle could be 0, could be 30, could be 45, could be 60, could be 90. No matter what the angle is, you're always at a distance from the pole of 5 units. And so what that does is it traces out a circle with radius 5. So you're going to be right, try to make this a little bit darker so you can see it. Okay, now for number 21, we have r equals negative 3 cosine theta. Now, one technique, okay, is to make a table. You can make a table like this. You could say if theta is 0, what's my r value? If it's pi over 6, what's my r value? And you can, plot all these points on your polar graph. Another technique that you might employ is think about this as a rectangular equation such as y equals negative 3 cosine of x. So what I would do is I'd say here's x and here's y, And the period is 2 pi, because 2 pi divided by b is 1, so period is 2 pi. Let's divide this up into 4 pieces. You learned how to graph sines and cosines earlier in Algebra 2 and earlier in pre-calc. So you can see these are counting by pi over 2, 3 pi over 2 is here, 2 pi. Okay, now the negative 3 cosine means that we start here at negative 3, go to 0, positive 3, 0, negative 3. So that's one cycle of our negative 3 cosine graph. But instead of thinking of this as x now, let's think of this as our angle theta. Instead of thinking of this as y, let's think of this as our r value, okay? So we're going to graph this here. We're going to say, okay, when I'm at an angle of theta, which is 0, my r value is negative 3. So if I'm here at an angle of 0, I'm going to have an r value of negative 3, which means I go through the pole, 1, 2, 3, I'm going to be right here. Now, when I go to pi over 2, so as I'm rotating to pi over 2, I'm going to be at 0. So this is going to be 0 right, pi over 2 is going to be 0 right here. And you're right at the pole. But look at what's happening here. So the r value is becoming negative, but less and less negative. So what happens is as I'm rotating like this, okay, the r value is negative, it means I have to go through the pole to the other side. So again, let's plot a couple more points just to get a sense of this. Say if we wanted to look at maybe pi over 3, okay. So I know that the cosine of pi over 3 is a half times negative 3 is negative 1.5. So what I'm doing is I'm saying when I'm at pi over 3, which is 60 degrees, like about this, I'm going to go through the pole 1.5, which is going to put me right about here. Okay. If I want to do another point, I could do, let's see, maybe, let's do pi over 4. So pi over 4 is 45. Cosine of 45 is root 2 over 2. It's about 0.7. Negative 3 times 0.7 is like about negative 2.1, roughly, okay? So that means that when I'm at 45, I'm going to be at 2.1. I'm going to be right about here. And so you can plot more and more points, but look what's happening is basically this part of the graph looks something like this, okay? And now what is happening here? Well, from pi over 2 to pi, okay, so when I'm going from pi over 2, 90 degrees to pi, you can see the r value is now positive. It's above the x-axis. And so what we're doing is we're saying at pi over 2, I'm at 0. At pi, I'm at 1, which is right here. How about when I'm at 3 pi over 4? Well, 3 pi over 4, we know the cosine is negative root 2 over 2, which is a negative 0.7, so this would be positive 2.1. So that means when I'm over here at 3 pi over 4, r value is positive, 2.1 is going to put me right about here. Now, a little bit of a hint here is that when you're working with a polar equation that's just in terms of cosines, that tells you that the graph is going to be a reflection over this polar axis, or you can kind of think of it as the x-axis. So all these points that I graphed here, I can reflect over, okay? And so you can see what's happening here is I'm actually getting, it's a circle, okay, like that. Now again, you can plot more points as you, either using this curve here, this rectangular curve to help you get some points, or you could just list out a bunch of points from 0 to 2 pi. But you don't have to do all of them if you know that cosine is a reflection over the x-axis here, this polar axis. So you could just go from 0 to pi and then reflect those points. Let me erase the whiteboard. Let's do some other polar graphs. Graph number 22 and 23, some different types of polar graphs here. We've got r equals 4 cosine 2 theta. Now, when it's in this form, a cosine n theta, or r equals a sine n theta, this is what we call a rose curve. Okay, a rose curve basically looks like a flower and it's got petals. The important thing is that if n is even, you get 2 times n number of petals. If it's odd, like 3, you get 3 petals. If it's 5, you get 5 petals. 7, you get 7 petals. But in this case, see, this is 2, which means we're going to have 2 times 2, 4 petals. So we'll just say rose curve, 4 petals. And now how do we get a good graph, a good sketch? Well, one thing we know is that this is in terms of cosines. That's going to tell us that's a reflection over this x-axis, or what's referred to as the polar axis. But let's go ahead and graph this as if it was y equals 4 cosine 2x. This is a nice way to convert it into the polar graph. So what we're going to do is we're going to say 2 pi divided by 2 is pi, Okay, so that's our period. And I'm going to divide this into 4 pieces. So our scale is pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is 2 pi. This is 3 pi over 2, 7 pi over 4. Okay, now cosine, it has an amplitude of 4. So it's going to start here, go down to here, here, here. Okay, so you know how to graph your sine and cosine graphs, right? So this is going to look like this. Okay, now let's go ahead and translate this to our polar graph. So at 0, our R value is 4. So I'm thinking this is theta and R. So at 0, the R value is 4. So 1, 2, 3, 4. So I'm going to start right here. Now as I rotate, as my angle gets bigger, see how the R value gets smaller, 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 until we get to pi over 4, which pi over 4, let's draw that pi over 4 line in here. At pi over 4, see the R value is getting smaller, smaller, smaller. It's almost like you're, if you're a fisherman, you're reeling in that, you're pulling it in, you're magnetically pulling it in. So it's turning, but at the same time it's getting closer to the polar, it's getting shorter, right? That R, so it goes like this. So that's this point right here, pi over 4 is 0. Now over here, as we make our way from an angle of pi over 4 to pi over 2, see pi over 4 to pi over 2, we're below the x-axis. That means our R value is negative. What happens when it's negative? Well, when it's negative, instead of going out this direction, we go through the pole the other direction to an R value of negative 4. Okay, so that means over here at pi over 2, we're going to be over here at, not at 4, but through the pole to negative 4. So what happens is this is getting longer and longer as you're turning, okay, like that. Okay, now, as we make our way from pi over 2, 90 degrees, to 3 pi over 4, which is right here, let's draw that 3 pi over 4 line in. The R value is negative, and it's approaching 0. So it's basically what you're doing. As you're turning, the R value is negative, so we have to go through the pole, and you're pulling back towards 0. So it's going something like this. Okay. Now, from 3 pi over 4, this is our 3 pi over 4 line. As we go to pi, see, 180 right here, the R value is getting longer and longer until you get to 4. At pi, you're at 4, which is right here. But what's happening, see, this is going out. See, 2 things are happening. You're turning and the R value is getting, see, this distance is getting longer, 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 like that, right? Okay, now we're at, right here at this point at pi. So now you might be saying, Mario, you told me that this is a cosine graph. It's just a reflection over the polar axis, right? So you could just take these points and reflect them, and you could get the rest of your graph. Can you see that? If I was to fold this, it would be a 4-petaled rose. But let's just keep going. I want you to kind of get a feel for this. So from pi to 5 pi over 4. So from pi to 5 pi over 4, we go from an R value of 4 to 0. So what's happening is you're turning, but you're also getting shorter and shorter. It's getting closer to the pole. Then as you go from 5 pi over 4, this line, to 3 pi over 2 here, the R value is getting bigger and bigger, but a bigger and bigger negative number. So what happens is instead of going out this way, you're going through the pole to the other side like this, okay? And that's right here. And then as you go from 3 pi over 2 to 7 pi over 4, the R value is, see, we're still below the x-axis. It's still negative, but it's becoming less and less so. So as I'm rotating from here to here, I have to go through the pole. This distance gets smaller and smaller. Okay, you're pulling it back into the pole. And then from 7 pi over 4 to 2 pi, the R value is positive again, which means we're going in the same direction. Okay, so 7 pi over 4 to pi, same direction. The R value is getting bigger and bigger until you go out to a R value of 4, like that. So you can see, here's your curve. I'll trace it again. So we're going like this, like this, like this, like this, like this, like that. So you can see 2 times 2, 4 petals. Notice it's a reflection over the polar axis or the x-axis. We're starting out here, and that's how you get your graph. So now a good thing to know is just to recognize the basic form though. See how it's a cosine n theta or a sine n theta. So let's do number 23 now, a different type of graph. R equals 3 plus 3 sine theta. This is in this form. R equals a plus or minus b cosine theta, or R equals a plus or minus b sine theta. When it's in this form, it's what's called a limaçon. Okay, limaçon is a French word for snail, and you'll see what this looks like in just a moment. But what you want to look at is the ratio of A over B. If it's less than 1, we have a limaçon with an inner loop. What's an inner loop? Inner loop basically means it kind of does something like this, okay? This is like the head of the snail looking right at you. This is like the shell in the background there, okay? If A over B is equal to 1, we have what's called a cardioid. Cardioid is basically like what you think of as like a heart shape, right? Okay. And then if A over B is between 1 and 2, we call it a dimpled limaçon. Dimpled means it's just kind of slightly, just a slight indentation there, okay, like a dimple, you know, on your face. And A over B, if it's greater than or equal to 2, we call it a convex limaçon. It's almost kind of like a circle, but kind of like flattened on one side, so to speak. So in this case, we can see that this is in the form R equals A plus B sine theta. A divided by B, 3 divided by 3 is equal to 1. So that tells us that, it's a cardioid. It's going to have like this heart shape to it. So that can kind of help us a little bit with our graph, just so we know what we're getting into. But again, I like this method of graphing in rectangular form. So see if you can follow me on this. I'm going to rearrange this a little bit. I'm going to say y equals 3 sine x plus 3. This 3 is going to shift the graph up 3 units, right? So 1, 2, 3. That's kind of like our midline, right? And it has a sine graph with an amplitude of 3. So it's going to go all the way up here to 6, down here to 0. This is a midline 3. Period is 2 pi divided by 1, which is 2 pi. So if I divide that into 4 equal pieces, this is going to be pi over 2 pi, 3 pi over 2. Sine starts at the midline. You know this already, right? So just to kind of show you, so here's our graph. Okay. And this is going to help us when we go to graph this. So it takes an extra minute, but it'll save you time on the other side. So starting off at an angle, theta of 0, our R value is 3. So here's 0, and I'm at an R value of 1, 2, 3 right here. Now, notice that this graph is in terms of sines only, right? That tells us it's going to be a reflection over this line right here, which is called the theta equals pi over 2 line, or you could kind of think of it as the y-axis. Now, notice what happens. See, as I'm going from 0 to pi over 2, 0 to 90 degrees, the R value is getting longer, longer, longer until it gets to an R value of 6. 1, 2, 3, 4, 5, 6, like this. But what's happening is, see, as you're turning, you're not just turning, you're actually going like further and further out like that. So you might want to pick some points in between. You could even estimate, you could say like, oh, maybe pi over 4 might be around 5 or something, you know, 1, 2, 3, 4, 5, maybe here. So you could kind of help get a better sketch. So you're turning, but you're getting further from the pole, okay, from the origin there. But then look what happens at pi over 2 to pi. It starts getting, the R value starts getting smaller. So you're going down here. So you're going from 6 to 3. So as I go from pi over 2 to pi, I'm going to go at pi, I'm going to be at 3. So this would be 1, 2, 3 right here, which makes sense because this is a reflection over the y-axis, or theta equals pi over 2. So I could even reflect this over here, be somewhere right about here maybe, okay? So there's that branch of the graph. Okay, now, as we go from pi to 3 pi over 2, so here's pi, 3 pi over 2 is here. The R value is getting, again, smaller and smaller until it becomes 0. So at 3 pi over 2, this distance here is getting shorter, shorter, shorter until it gets to 0. So it's almost like it's reeling it in. You're pulling it in magnetically, like 0, like that, okay? Now, again, we already know that this is a cardioid, heart shape, something like this. We know it's a reflection over the y-axis, or the line theta equals pi over 2. I could just kind of finish this off, but notice as you go from 3 pi over 2 to 2 pi, now the R value is starting to get bigger and bigger until it reaches 3, which is right here. So again, you're turning, but you're also like letting out that, what's the word, like the line on a fishing line, you know, it's being, this distance is getting further, further, further. Okay, so there you can see, I'll make it a little bit darker so you can see it, but basically it's a heart shape. Okay, you've got some key points there. And that's your graph. So let me erase the whiteboard. Let's do some more polar graphs. For 24, let's do another polar graph. We want to graph R equals 2 minus 3 cosine theta. Now, just for reference, you might want to recognize the form that this is in. It's in the Limaçon form, let's write this down. So this is like r equals a minus b cosine theta. So notice the ratio of a over b is equal to 2 over 3. You don't have to worry about the plus or minus, just the a and the b, 2 over 3. So that tells us that it's a over b is 2 or 3. It's less than 1, which means that it has an inner loop. So it's a Limaçon with an inner loop. So it should look something like this, roughly. Okay. Now, let's go ahead and graph it in the rectangular form. So if we were graphing y equals negative 3 cosine x plus 2, I'm just rearranging this. Plus 2 means it's shifting up 2. This is like our midline. And it's a cosine graph with an amplitude of 3. Okay, so what we're doing is we're saying that starting from here, amplitude of, this is negative 3, we're going to start down right here at negative 1. And the period is 2 pi. So our scale is going to be pi over 2. And then what's going to happen is it's going to go to here, then to here, then to here, and then down to here. So it goes something like this. Now we're going to use that to graph over here. So we're going to say at 0, an angle of 0, we're at an r value of negative 1. So 0, we're going to actually go through the pole. Negative 1 would be right there. Now, somewhere in between 0 and pi over 2. Okay, now you could calculate this, be very precise, but I'm just going to estimate. It looks like it's maybe a little bit past halfway, so maybe a little bit past pi over 4. So a little bit past pi over 4, it's going to go to 0 here. Okay, so what's happening is, as we're turning, okay, the r value is getting smaller and smaller. It's negative, so that means instead of going out this way, we're going through the pole, and at about roughly pi over 4 or so, it's going into 0, like right about here. Okay. Now, from roughly pi over 4 to pi over 2, the r value turns positive. It's above the x-axis, and it's going out to an r value of 2, and that occurs at 90 degrees or pi over 2. So what's happening is, as we go through, it goes something like this. Now, from pi over 2 to pi, it makes its way out to 5. So let's see, so at from pi over 2 to pi, that's going to be 5. So that's going to be 1, 2, 3, 4, 5, right about here. So it's turning, but it's also getting, longer and longer, the distance from the pole. Now, from pi to 3 pi over 2, r value is getting smaller, and it approaches 2. So that's going to be, let's see, right about, let's see, at 3 pi over 2, 2 would be right about here. But again, we notice this is cosine, so we know it's a reflection over this polar axis. So I could pretty much just do the mirror image, but just to kind of continue on like this. Then what happens from 3 pi over 2 to roughly somewhere in between 3 pi over 2 and 2 pi, maybe 7 pi over 4 roughly. This is 7 pi over 4. It's going to come down to an r value of 0. So again, you're reeling it in. R value is getting smaller and smaller as you rotate to this line here, about 7 pi over 4. It's going to 0 into the pole. Then from roughly 7 pi over 4 to 2 pi, the r value is negative, which means we're going, as we're turning towards 2 pi, instead of going out this way, we're going through the pole like that. So there's your inner loop. Let me see if I can make it a little bit darker here so you can see it a little bit better. Like that. There's the inner loop. And again, cosine reflection over that polar axis. Okay, for the next 3 graphs, they gave us the graph, but we want to write the equation, both in rectangular form and polar form. So a little bit of a challenge here. Now, this one, you can see that this is like a 45-degree line here. So I could say that this line here is the line theta equals negative pi over 4, or I could say theta equals 3 pi over 4. That's a couple options for the polar form. Rectangular, I can see that this has like a slope of -1. So I could say that this is y equals -1x. Now, if you need some help, and sometimes it's easier to do it in one form than another. Like I might say, theta equals 3 pi over 4. Let me take the tangent of both sides. So tangent of theta equals tangent of 3 pi over 4. Tangent of theta, I know, equals y over x. So I can make that substitution, y divided by x. Tangent of 3 pi over 4 from our unit circle, we know is -1. If I multiply both sides by x, I get y equals -x. So couple different ways to do it. One form might be easier to start with than another. Let's do 27 and then come back to 26. 27, this is just a horizontal line. That line we know is y equals 2. That's our rectangular form. But to change it into the polar form, we know y equals r sine theta, right? So let's replace that with r sine theta. Divide both sides by sine theta. The reciprocal of sine is cosecant. So I could write this as r equals 2 cosecant theta. Again, both of these equations describe the same graph. It's just that one's rectangular, one's polar. Okay, for going back to 26 now, it looks like we have a circle, and we know that the standard form of the equation of a circle is x minus h squared plus y minus k squared equals the radius squared. In this case, the center is at 0, -3, so this would be x squared plus y plus 3 squared is equal to, let's see, radius of 3, 3 squared is 9. So this would be our rectangular form. How do we turn it into the polar form? Well, you might know the equation for this. It's kind of like a rose curve with one petal, and it's a reflection over the y-axis, so it'd be in terms of sines. We could write this as in this form right here, but you might not recognize that, so you might want to do a little bit of substitution here. So we could say x is equal to r cosine theta. So if we square it, that's going to be r squared cosine squared theta plus, actually, let me do this a different way. Let me FOIL this out. So this is going to be x squared plus y squared plus 6y plus 9 equals 9. If we subtract 9 from both sides, this would equal 0. Now, x squared plus y squared is equal to r squared, okay, right here. Y is equal to r sine theta, and that's equal to 0. So now if we subtract the 6r sine theta and divide both sides by r, we get r equals -6 sine theta. And again, like I was saying earlier, see, it's in this form. There's one petal, so n is 1. Okay, it's a sine because it's a reflection over the theta equals pi over 2 or the y-axis. The negative means it's going to be down here. If it was positive, it would be up here. So you could use this to help you get this equation, or you can do the substitutions. Let me erase the whiteboard. Let's do the next group of problems. Okay, for number 28, let's write the equation of this polar graph in polar form. So how would you write this equation? Well, we can see it's a rose curve, and it has 3 petals, and we can see it's a reflection over this polar axis or this x-axis, right? So that means it's going to be in this form right here in terms of cosine, since it's a reflection over the polar axis. And since there's an odd number of petals, n would be 3. Okay, so remember, if it's odd, if this number is odd, it has the same number of petals. If it's even, you have to double it. You would have twice as many petals. So in this case, the equation would be r equals, now notice the length of the petals, 1, 2, 3 units long. So that's going to be what this a value is here. It's going to be 3 cosine 3 theta. That's your equation. Okay, for number 29 now, find the distance between these two polar points. And this is another formula you might want to add to your formula sheet over there on the right. It's r1 squared plus r2 squared minus 2r1 r2 cosine theta 2 minus theta 1. Take the square root. You might recognize this formula from the law of cosines. That's what it's based on. Again, if you want a picture, we can kind of draw a little diagram just to kind of visualize what's happening here. These points, all right, let's see, negative pi over 6 is here. Negative 2 means we go through the pole, so that puts us right about here. 4, negative pi over 3 would be 1, 2, 3, 4. Negative pi over 3 is right about here. So kind of think of this as like, here's your r value, here's your r value, here's the angle between those two, and we're trying to find that distance right there, okay, that shortest distance. So again, using this formula, what we would do is we would say, okay, negative 2 squared plus 4 squared minus 2 times negative 2 times 4 times the cosine of theta 2 minus theta 1. Okay, so theta 2 minus theta 1 is negative pi over 6 minus negative pi over 3. So negative pi over 6 minus negative pi over 3. Okay, and then you take the square root. Okay, so that comes out to, let's see, 4 plus 16 is 20. And this comes out to, let's see, negative 2 times negative 2 is 4 times 4 is 16. times the cosine of, let's see, negative pi over 6. This is like adding the opposite, so that's like 2 pi over 6 minus 1 pi over 6 is pi over 6. And then we take the square root. So let's see what that comes out to. Let's see here. This is a negative times a positive. Okay, so this would be 20 plus 16. Now we can do this on the calculator. You can also do it by hand. So cosine of pi over 6, that's 30 degrees. That's going to be square root 3 over 2 times 16. So that's going to come out to 8 root 3 plus 20, and you could take the square root like that. You could even factor out a 4 if you wanted. This would be 2, 5 plus 2 square root of 3 like that. Or you could do it on the calculator. So this would be, let's see here, it's square root of 20 plus 8 square root of 3. About 5.8. Okay, is that distance. Let me erase the whiteboard. Let's do the last couple questions. Before we do these last 2 questions, I just wanted to let you know that if you're preparing for like a pre-calculus final exam here shortly, you might want to join the channel at the additional videos level, and you can get access to both my pre-calculus midterm exam review and my pre-calculus final exam review. So if you like the way that I explain things, you might want to check those out by joining as a channel member at that additional videos level. But let's go ahead and do these last 2 examples. We want to write these equations in the polar form. So this is in the rectangular or xy form. And so what we can do here, this is supposed to be an x, what we can do here is we can replace y and x with what y and x equal. We have y is equal to r sine theta, and x is equal to r cosine theta. We can divide both sides by r, cancel those out, and we can divide both sides by cosine theta, which gives us sine over cosine, which is the tangent of theta. And then if we take the tan inverse of both sides, what a tangent of what angle equals negative root 3 over 3? That would be negative pi over 6. So now we have our equation in the polar form. Theta equals negative pi over 6, which, again, if you graph this, negative pi over 6 would be this line right here, which is a line with a slope of negative root 3 over 3. Now for number 31, last problem, we want to go from this equation of a circle in rectangular form to polar form. I'm going to FOIL this out and just write this as y squared minus 10y plus 25. Subtract 25 from both sides. X squared plus y squared we know is equal to r squared. We had a problem similar to this earlier. Y is equal to r sine theta. Let's go ahead and add this term to the other side, so that equals 10r sine theta. And if we divide both sides by r, we get r equals 10 sine theta. So great job if you're able to follow these 31 examples. Good luck on your polar exam review, or test I should say, and I look forward to seeing you in some of my other videos. If you want additional help, I'll put a playlist there to some of my other polar videos. You can check more of those out there, and I'll see you in my other videos.